Good morning, everyone, and welcome to Druid Summit 2022. My name is FJ, and I am one of the original authors behind Apache Druid. I'm currently on the Druid PMC, and I'm also the co-founder and current CEO of Imply, which is a company really built around Apache Druid. I really want to thank you guys for being here this morning. And what I want to talk to everyone about are some of the key trends that's happening in our space, some of the new requirements that we see in the world of analytics, in the world of applications, some of the new use cases we see emerging as part of our space, and where Apache Druid fits in all of that. So for those of you that may be new to the Druid project and the Druid community for the first time, I want to welcome everyone and I want to say thank you for checking out this project and seeing if it could potentially solve any problems that you might have. For those of you that are longtime members of the community, I want to welcome you all back again. For those of you that may not know, the Druid project was actually started about 10 years ago, and it was initially started to power a user-facing analytics application. This is an application where people could click on buttons and very quickly and interactively get insights and answers to questions that they're asking. Today, we see that our original use case as still the fundamental value that Druid provides. And more so, we think about Druid as sitting in this intersection between analytics and applications, and that it is a really good platform to build user-facing analytical applications. I see the Druid project as being more relevant than ever towards providing value for kind of the core competency it was built for. In particular, when I look at the analytics and application world today, I see kind of three really big emerging trends that are happening in the world of data. The first trend is what's happening in the analytics world, and that analytics are really expanding beyond traditional reporting and traditional BI. The second big trend I see is around applications and how user-facing applications are really expanding beyond their traditional LTP roots. And the third trend I see is the rapid proliferation of streaming data, and that streaming data is becoming ubiquitous within every company, and there's a lot of new exciting use cases that are emerging because of the adoption of streaming data. So I want to go a little bit more detail about each of these trends and actually how Druid fits and provides value in each of these trends. So the first trend is around what's happening in the analytics world and how analytics is expanding beyond traditional reporting as well as BI. If you look at a traditional analytics or BI workflow, this workflow has been around for many years, and there's kind of a known set of people or known set of personas that are usually involved in this workflow. You have some business user that has a set of business questions and wants to use data to drive decisions. The business user usually interacts with some sort of data analyst, and the data analyst is an expert in working with data. The data analyst typically uses a BI tool to create a set of reports, and this BI tool pulls data from a data warehouse. The results get passed back to the BI tool, those results get passed to a data analyst, and then the results finally go back to the business user. This is a very popular workflow, but I think it has certain assumptions built into it that are becoming less relevant as analytics are getting more powerful and the tools that drive this workflow are getting more powerful as well. So the first fundamental assumption is with this workflow is that it's okay to wait for results. And what I mean by that is the business user might be okay working with an analyst and there's some delay in communication and workflow there. The analyst has to use a BI tool. The BI tool has to take a data warehouse. And in each of these interactions, there are certain delays that occur. So one of the fundamental assumptions is that this delay is okay. It's fine to wait minutes. It's fine to wait hours for some answer to some question that someone may have. The second assumption is that working with data is concentrated into a small group of users, a small group of highly specialized users. And the data warehouse itself is only really serving queries and a predefined set of queries from a BI tool. So data warehouse is serving a limited set of very ad hoc queries from potentially many disparate sources. So there's a limit on the concurrency of queries that's being served by the data warehouse. The third assumption is that a level of caching is okay for some of these reporting dashboards. And the idea is that the data on the dashboards isn't changing very much. The types of queries that these dashboards are making are generally limited in nature. So it's a very reporting heavy use case where there's a lot of predefinition into the questions that are being asked and the answers that people want to see. So the trend that we're seeing in the world of data right now is that use cases, in particular analytical use cases, are fitting into two broad buckets in terms of tools and in terms of how data is used. So the first bucket is what I talked about. This is traditional reporting, where you have a data analyst that works with a business user and a BI tool and a data warehouse to generate more pre-canned or predefined reports. The second trend is the one that we see most often in the Druid world, in which a new breed of analytical applications are getting built. These applications are designed to be used by a very broad set of users, and they're also very, very flexible in the types of queries they can make and the types of exploration you can do on the data. And these two buckets, if you actually look at the requirements for them, they have very different requirements in terms of how fast queries need to complete, as well as the number of concurrent queries that get sent to the back end at any given point in time. So for more traditional reporting, a lot of the times you need a lot of flexibility in the types of queries you can do, but those queries don't necessarily need to be very quick, and you don't necessarily get a whole lot of queries that are issued at the exact same time. In the second use case around these more modern analytic applications that need to be much more interactive and much more real-time, what you see is a different set of requirements. Queries have to complete very, very quickly, and lots of users might be using the application at the same time, which is generating very high query concurrency. The latter use case is really why we built Druid in the first place, and is still the top use case by far of how people use Druid today to power these kind of next generation modern analytical applications. So to kind of give you one example of a community company that leverages Druid actually to build a next generation analytical application, there's Salesforce, who has actually written quite a bit of really neat content towards what they're doing. So Salesforce has built an observability platform. They call it the Edge Intelligence Observability Platform. And this platform has all the features and requirements of a modern analytical application. It's designed to be used by tens of thousands of concurrent users. Queries have to complete generally in under a second, and the slowest queries have to complete in most a few seconds. And this is on very, very high volumes of data. So this application and this workload doesn't fit very well into the world of traditional BI, but is a great fit for the more modern analytical application that we've been talking about. So the second major trend I want to talk about is the trend that's happening in the application world. When you think about a modern kind of web application, people usually tend to think about OLTP applications, but we're also seeing a lot happening in the world of data-driven applications, and that there's increasingly more data-driven applications that are getting built. So one of the kind of interesting trends that we're seeing around modern web or SaaS applications is that developers are increasingly building analytics directly into their web native products or web native applications. So one example of this is a use case at Atlassian, which they've publicly talked about. Most of us have used Confluent as a product for building our internal wikis. And underneath Confluent is a bunch of transactional databases that store data around these wikis and retrieve data when you actually use the Confluent product. But what's interesting is that Atlassian as a company has launched integrated user behavioral analytics as part of their Confluent product. So when you use Confluence today, you can actually get insight into how your internal wikis are getting developed. You can actually look at data and trends as towards how users are engaging with these wikis and which wikis are the most popular. And this is kind of an example of a general trend that we're seeing in the world of application development. Increasingly, data is playing an important role into how these applications are getting built and how they're getting launched as well. And this data is not just data in the backend, it's data that's getting directly exposed to users, and the users leverage this data for a variety of different purposes that ultimately make for a better product or application experience. So one of the most common questions that we get is why don't we just use a transactional database for our application analytics as well? Why don't we actually expose analytics to our users using whatever transactional database, for example, MongoDB or Postgres, that we're already powering the rest of our application with? So I think it's like very natural for developers to want to use a single system for all of their use cases. I know when I was a developer, that's what I wanted as well. Like, why bring in other databases when you don't have to? But the truth is, with a lot of folks in our community and a lot of customers at Imply as well, is that we find that transactional databases simply aren't purpose built for analytics. And at sufficient scale and a sufficient query concurrency, you get the phenomenon of the visualization I'm showing on the screen, which is queries can simply take a very long time if they complete at all. Very complex analytical queries don't map very well to how transactional databases store data. They don't map very well to how transactional databases process data as well. So when we actually started the Druid project, we tried to use a transactional database to power an analytics application. We used one of the Postgres derivatives, but we got the problem exactly as I described kind of in the prior slide, which is that queries simply took too long to come back. And what we realized at that time is that you have to use the right tool for the job. And if you're building an application or you're building some sort of user-facing analytics functionality, you have to use a database that's really purpose-built for analytics. This is kind of the core idea behind Druid. It's a system that's really designed to answer analytical queries very, very quickly. It's a system that's designed to do large-scale aggregations, large-scale group bys, as well as more complex queries such as distinct user count or even histograms and quantiles as well. So to give you an example of what I've been talking about, one of the members of the community, Cisco Thousand Eyes, has actually built an externally facing analytics applications that has very different requirements than what a traditional transactional database is able to provide. They have to do very large-scale aggregations. They have to do filters and group bys on highly dimensional data. And initially, they tried to use a transactional OLTP database to power this user-facing application. The query performance really, really struggled, and then they switched to a much more OLAP-oriented database such as Druid, and their application has been able to demonstrate much better performance and provide their end users with a much better experience as a result. So the third trend that I want to talk about is around streaming data and its growing adoption within really all companies out there, and kind of the new use cases that are emerging as a result of having streaming data become much more proliferant. So streaming technologies such as Kafka, Kinesis, and Apache Pulsar, they're really getting adopted everywhere. Almost every company I talk to tends to have a streaming message bus in place. And increasingly, their data delivery and data transformation layers are becoming very stream-oriented. So one of the things that most excites me about working with our customers, as well as members of the community, is this conversation around what more can we do with streaming. Many companies that we work with actually already have deployed some sort of streaming message bus, such as Kafka, and some sort of streaming ETL layer, such as Apache Flink. And the conversation revolves around the query layer. What more can we do with streaming data if the query layer is natively designed for streams? And in practice, what we've seen once the query layer becomes a very stream native is that the workflows get much more operational. So as opposed to doing kind of more static reporting or more static analysis on batch data, we're actually able to analyze everything that's happening in the moment. So to be able to compare events that are happening in the moment to what may have happened previously, to be able to triage and diagnose problems as they're happening in the moment and be able to make decisions live versus having to wait several hours or days in order to make those same decisions. At the same time, we're able to do much more complex real-time alerting. So to be able to alert on very complex situations and to be able to generate alerts that compare what's happening in the moment to what may have happened days, months, or years into the past. So in order to unlock, I think, the true power of streaming, every part of the data stack that's involved in streaming must be built natively for the stream. When any piece of the data stack is not built natively for the stream, you have a bottleneck in your overall stack, which ostensibly forces that stack to be a batch system instead of a true streaming system. This is one of the philosophies that we had when we first started working on Druid, and it's a philosophy that still continues today as we add more and more features to have better support for streaming data, as well as better support for the message buses and ETL technologies that people often use for streaming data. So if you didn't know this, Eric, who actually started the first lines of code on Druid and is one of the original creators behind Druid, actually used to work at LinkedIn, and he was there when the initial work on Kafka first started. So Druid has been built to work well with Kafka since the very, very early days of Kafka. And we've extended the philosophy of being able to work well with stream native technologies to Kinesis and Pulsar and Flink and many other types of streaming technologies. In particular, we look a lot in our roadmap to ensure that we can do exactly one suggestion from streaming systems, that we guarantee consistency. We have very high scalability in working with the largest streams out there. We have continuous backup in terms of the data that we ingest for a stream, and that there's effectively lock-free ingestion when data comes in, and we can also query data as soon as it comes in. So from the very early days of Druid and continuing to our roadmap, we've really been developed around this idea of a stream, and that data should natively come in as a stream. I think over time, we've seen other companies start adopting stream native stacks as well. In particular, I always like this example from Confluent, which they've talked about publicly a couple of times. Confluent internally has a stream native stack as well. Obviously, Kafka is a huge part of that stack, but Druid is actually used as the stream native query layer to power a bunch of their different applications, including applications around billing as well as observability. So if you're thinking about powering a project with Druid for the first time, and to summarize kind of the key ideas behind this talk, if you're looking to build a user-facing analytical application where you want to have a bunch of users use that application at the same time, and for each of those users to get very fast interactive queries and to have a really great user experience, Druid is a really good fit for your use cases. If you have streaming data and you want to build a stream native stack where every piece of that stack is natively built for streaming data and there's no bottlenecks anywhere in that stack, Druid is also a very good fit. And these are trends that we see across thousands of different organizations out in the Druid community. And these are the areas that we focus on at Imply as we continue to build Druid to fit in the modern data stack. So when we build Druid, we actually have a fundamental set of design principles in mind. These principles always relate to what I actually talked about in my prior slides, and there's a set of things that we always try and ensure that Druid is very good at. The first is we believe the primary value add of Druid is around performance. So when we have to make trade-offs in the system, we always try and ensure that any analytical query that Druid answers is designed to be as fast as possible. And the vast majority of queries that Druid answers or Druid can answer can complete in under a second, regardless of the scale of data. The second focus of developers on Druid is to ensure that the performance that we can provide to end users is completely scalable regardless of the concurrency that the system is currently going under. So no matter how many queries get sent to the system at any given point in time, Druid should be able to provide kind of a consistent performance and consistent query performance for any of those queries. So the third design principle behind Druid and what we continue to focus on is that it works really, really well with streaming data. Druid does have a batch load system as well. We actually also try to ensure that a batch load system is best in class. But I think really what gets us excited is to always ensure that Druid works super well streaming data, that it can handle all different types of streaming data, whether it's nested or no matter how complex that it is. So one of the most common questions I always get for Druid is, how do I think about it? Is it more like a Snowflake, or is it more like a Mongo? Is it a data warehouse? Is it a transactional database? And Druid as its core is neither. It's actually its own category and its own class. For better or for worse, what everyone has been calling this category is real-time analytic databases. And the idea behind Druid and all real-time analytic databases really is that it takes features and capabilities from data warehouses and also features and capabilities from transactional databases as well. It is a system that is very much designed to be read optimized, so to answer queries very quickly. It's a system that's designed to power user-facing applications. So there's ideas from both warehouses as well as transactional databases that are baked into Druid. So the one thing I hope you take away from this talk, and when you think about where to use Druid in terms of your data stack, I think if you are powering some sort of user-facing or customer-facing analytics application, if you need queries to complete very fast, if you're working with streaming data, Druid tends to be a very, very good fit. And I think it's a system that is like really purpose-built to power these user-facing applications. So we do all of our development in Druid as part of the Druid community. We open source pretty much everything that we do on Druid. And if you're ever interested in joining the Druid community, I highly encourage you to check out the website. Our community has been growing very rapidly over the last few years. And part of that is, I think, driven by the fact that there's a lot of new types of analytical applications and new products that folks have launched, and we're always very interested in hearing about new use cases and new applications of the technology, and it helps inform our roadmap and where we want to take the database. So at Imply, Druid development is a very high priority of the developers at this company. We spend a lot of our time building out Druid really for the community. But we also have a commercial product as well that's called Imply Polaris. This is a SaaS hosted version of Druid. And if you ever want to kind of kick the bucket with Druid and just try it out for the first time, or even if you have a real sizable production use case that you want to launch, Polaris is probably the easiest way to get started with Druid. And oftentimes we see it being easier than downloading Druid yourself and then trying to run it yourself as well. At Imply, we always try and ensure that we're creating a lot of value for the Druid community as well as for our customers as well. We recently launched a program called the Total Value Guarantee, where we promise that the cost of running Druid as part of Imply is actually going to be much cheaper than running it yourself. Lastly, if you ever want to know more about Druid, want to know about how Druid fits into a modern data stack, streaming data, or even some of the broad concepts that are happening in the data world, we're launching a podcast that talks about all of these topics and more. We hope to have speakers from the Druid community as well as the broader data community be a part of this podcast, so make sure to check it out. All right, so that concludes my talk. I hope you got some value out of listening about the different applications of Druid and how you can use it and the different ways that it can potentially help some of the products or applications that you're building. I want to thank you again for attending Druid Summit. We have a lot of other talks around the roadmap of Druid, some of the new exciting developments that we have coming up, and even some of the new products that we're launching at Imply. So thanks again.